Hello everyone, my name is Khalid Mahmoud and I am doctoral candidate number 2 in Innova project. In this presentation I will talk about the vibrating plates with opening in vibro-acoustic systems. I will take mainly about 2 points. First one will be the influence of these openings on the vibrating plates and how it affects the vibration and the sound response of these plates. And then I will conclude with the optimization of this opening design using some optimizations algorithm. So let's imagine we have this traditional washing machine and we want to control somehow or use the sides of this washing machine to affect the sound or the noise emitted from its motor. So some work has been done already by applying the active noise control system to these washing machines and attaching some vibration actuators to the walls of the casing. To have more insights about this application, I will refer you to the noise control casings books, where you will find a lot of more into details information. But the bottom side of this washing machine usually has an opening. This opening can help to do some maintenance for the motors or to dissipate the heat inside the casings. Some companies are trying to reduce also the sound that will be leaked outside of this opening by tapping or using some kind of cover for the sides. But it's not very practical because if one of these screws is loosened, so it will actually enhance the emitted noise. So we are trying to cover this side by a plate and having an opening in this plate and apply some active noise control for these vibrations of the plate. This is one of the examples of our work. To start, we need a model. So first we used an analytical modeling using Rayleigh-Ritz methods, which give the flexibility to introduce our system to different programming languages, and also it's faster to be processed. And also we used finite element modeling using COMSOL to give some visualization of the interaction between the sound pressure inside the casing and the vibration of the plate. For any model, we need validation. So we run an experiment. As you can see, we have a concrete enclosure with a vibrating plate, and this is just one of the trials by having the opening as circular in the middle. And we can measure the sound escaped from this casing by 2 microphones. And also there is a laser vibrometer to measure the vibration. The validation, as we can see here, this short video, we can see the mood shapes from COMSOL simulation, and also we can see just here the 5th and the 11th mood from the analytical model. We see quite good consistency of the results between both models. From the results, we tried different shapes of the opening. So configuration 2, as we saw later on the experiment, it has a circular opening in the middle. And we shifted this opening to one of the corners, and we also tried to divide this opening into smaller one, reserving the same total area. And here we can see the effect. When we shifted this opening, so we changed the stiffness distribution of the plate, we actually introduced additional resonance onto our system. And comparing configuration 2 to configuration 4, we divided the contour of the opening into discrete ones, like smaller areas, and this is introduced higher resonance on the system at the frequency 180 Hertz. And this is also due to the distances between these openings and the corners, and also the position of these openings into the nodal areas and the anti-nodal areas of the mood shapes of the vibration of the plate. So if you decided to divide your opening into smaller openings, you need to be very careful because you might enhance the response of your system. To have more ideas and details about the work and much more openings trials, I would refer you to this link where you find our recent publication related to this work. Okay, but if you need more precise design of the parameters of this opening, you can try some optimization algorithm. And actually, we tried some genetic algorithm. So we started our work with initial population. So it's the search space, which will have different shapes of the openings. And we initialized the system by giving some parameters for this opening. For example, the diameter, the position on the two axes, and so on. And then we pass this initial population into our analytical model. So we measure the performance of the system, which we call the fitness value. And then we will decide if this fitness value is acceptable or we need more trial. So if our fitness value or the performance of the system is kept good for a certain number of trials, so we will terminate, and this will be our optimal or best individual. If not, so we will do one or two of the basic steps of the genetic algorithm, which is crossover. So we will take two of the individuals and switch their parameters to have a new one, or the mutation, which is randomly picking some diameter, for example, which is 0.1 meter, and make it randomly, let's say 0.12 meters. And we will have then a new individual. Then we will take these new individuals and pass them to analytical model and getting the new fitness and so on until we terminate. And then the result will be the optimal shape and position of this opening. And this will lead us to the optimal design of our openings. But to do that and to do our work experimentally and in application, we actually need to consider something related to the latency and the accuracy of our signal processing. And for that, my colleague Chao will talk about it on the next presentation. Thank you so much.